Dear students, in the earlier class, we have explained that the coordinates in a frame of reference which is moving with a relativistically high velocity changes as per the Lorentz transformation equations, and we have derived those equations also. Since the coordinates x, y, z and t, time also changes according to Lorentz transformation equations. Therefore, the time measured by a clock in a moving frame of reference will changes when we measure the time interval of an event. So, according to these equations, relativistic physics, the time interval shown by watches in a moving frame increases as a result of the fast moving of these charges. That phenomenon is called as time dilation. Time dilation. So, according to physics, relativistic physics, all moving clocks run slow and shows longer time interval of an event. If any event is measured, time interval of any event is measured in a moving frame, that time interval increases because the moving clocks will run slow. This is called a time dilation. This is called time dilation. Time dilation. So, as this time interval measured by an event, time interval of an event depends on relative motion, relative velocity. It depends on relative velocity of a frame of reference. Now consider two frames of reference. Say one is S dash, another one is S. The origins go onwards. Let an observer present in a frame of reference, S, which is at rest, measure time interval in a watch of any event with a watch. So, let an observer measure time interval of an event with a watch in a frame of reference yes, which is at rest. If the frame of reference S is at rest, I conducted an experiment and measure initial and final time interval, time shown by the watch. So, if T1 and T2 are times shown by the watch, then time interval of an event T is equal to T2 minus T, final time minus initial time. Suppose if the same event is conducted by an observer in a relativistic frame which is moving with velocity v, then he will get different time intervals. He will get different time intervals. Therefore, for an observer in S dash frame moving with velocity, moving with certain velocity, appears as T dash is equal to T2 dash minus T1 dash are the same event. Same event has been conducted. Experiment is conducted in another with respect to S dash frame. The time intervals found to be T2 dash and T1 dash. Therefore, time interval is equal to T dash. That is equal to T2 dash minus T1 dash. So, this is equation number 1 and this is equation 2. Now, according to Lorentz transformation equations, from Lorentz transformation equations, time interval T1 dash is equal to, we take this one, T1 minus Vx by c square divided by 1 minus v square by c square and the square root. T1 dash is equal to T1 minus Vx by c square divided by square root of 1 minus v square by c square. This is the initial time measured by an observer who is present in a moving frame S dash. Similarly, for another time interval, final time T2 dash is equal to T2 minus Vx by c square divided by 1 minus v square by c square square. So this is the initial and the final time. Substitute in 2 equation 2. Therefore, T is equal to T2 dash T2 minus Vx by c square divided by 1 minus v square by c square under root minus T1 minus Vx by c square divided by 1 minus v square by c square. Because the position does not change the relative position, therefore x is same in both equations. And therefore this is equal to, these two gets cancelled. Therefore t is equal to t2 minus t1 divided by square root of 1 minus b square by c square. That is also equal to, sorry, this is t dash, t dash, t dash. Therefore, t dash is equal to t2 minus t1 is equal to t from equation 1. t2 minus t1 is equal to t. Therefore, t dash is equal to t divided by 1 minus b square by c square under square root. Now, because denominator 1 minus b square by c square is less than 1, therefore t always less than t dash. In the other way, t dash is greater than t. Therefore, since 1 minus b square by c square under root is less than 1, therefore t dash is always greater than t. Therefore, relativistic time is more than that of the normal time, classical time. Normal time. Classical time, if we measure in a frame of reference which is at rest, because this time interval is longer, therefore there is a delay in the time shown by the watches. This is called as time dilation. Now, therefore, suppose if this clock, how this clock should run slow means, suppose there is a clock 1 in a frame of reference, yes, and that will show a time interval 12:10. Then this clock will show, say this is the 12:15, say 12:15, and this clock will show a time interval as 12:05 like that. 12:05. This is 12, this is 15 minutes. Therefore, this clock will run slow when compared to the clock which is at rest. This phenomena is called as time dilation. Therefore, if we want to have more time for a day, more than 24 hours, you keep on moving in a frame which is moving with very high velocities. Okay? So, this is the case. Now, why the time interval is more for an observer who is present in a moving frame of reference? Means that can be explained in this manner. Suppose if there is a frame like this, if an observer measures time interval from here is an event that is occurring at AB or at A. Let an event is occurring at A, and an observer is present at O, at rest. Then, if we send a light signal to the watch, then towards the event, then the signal will go vertically straight towards the point A, and again it will reach to the observer This is initial time T1, this is final time T2. Therefore, T is equal to T2 minus T. Suppose if the same frame is moving, then for an observer, when he sends a signal, as soon as the signal reaches the observer, he will reach here because he is moving with certain velocity v. Therefore, there is a longer distance the signal has to travel. Therefore, this is T1 dash, and again when he receives signal, reflected signal, he will receive here. So in the second case, the light signal is traveling a larger distance, and it will take longer time. Therefore, T dash is equal to T2 dash minus T1 dash is greater than that of T. So this is the reason why the time interval increases fast by measuring the time interval of an event because of this reason. Because when the frame is moving, the signal has to travel longer distance. Therefore, for a given velocity, if the distance is more, it will take more time for traveling. Therefore, that's why the time dilation occurs in the equation. So, this is about time dilation. So, we should write all this